Welcome back. This is Paul, and on the bench today I have this GE fan motor sent in by a customer for repair. And he sent the components, the pieces in a separate bag, the screws, speed coil, bottom plate. There's a lot of different pieces, a wire cord that's going on it, and the base plate, which says it's a GE 1.3 amps, 60 cycle fan. Can't read the number on there, but the catalog number is 78X233. Spec number 273006-1. So there we have it, and we're going to figure out what's wrong with it. I'm going to get this plate out. And it's tight. Let's see if we can get that out of there without causing it any harm, because it is brass. And am I the right height? Yeah, I think you can see that. I could drop it down a little bit. Hold on just a second. Bear with me. There you go. That's probably a good height right there. Alright. Okay. This has a brass, or it's sort of like a bearing. It's a ball joint, and that turns in there. Get a little bit of cleaning stuff here, so as we go along we can clean this a little. Get some liquid gold. Okay. Now let's see if we can push that back in. A little oil on there, see if we can get that out of there. Okay. And it's got a little bit jammed up here at some point. That's it. We're doing good. Page. On the armature. When it's coming off, they can be a little bit stubborn, especially when the armature shaft is a little bit out of round. And this one don't want to hurt it. So I'm going to put a little piece of felt here might do. See if this needs to be sharpened. Okay. And something a little bit stronger than what I'm using. Get it back out there. I'm going to have to swing it down a little bit to get over that shaft. Yep. Okay. Let's put it back on. Okay. Okay. That. Not seeing much of it. There's a little bit of a rise at the end there, but not a lot. Just a little bit here and clean that off. Oil. It's loosening. Just hitting on it. Get something to it. That should just come right off that shaft. Yeah, we're going to put the armature out. Well, that works too. Let's take this coil out of there. The wire's not in bad shape, but we got to get this off. This has got to go bye-bye. So let's start up there. Somebody tried to take it off before, and it looks like they used pliers, and you don't want to do it on a brass fitting, and they just tightened it. I mean, they use big pliers, not little delicate things like I'm using here. Right now, let me see if we can get that off. Okay, I'm working on it, and I got it off. Yeah. Okay. And that's what it is. That's what it looks like. Let's get it some more light here. Let's see. And it's just a sleeve. Some people call them sleeve bearings. It's not really a bearing, it's just a bushing. And the armature turns in that. They make them out of brass because it's soft metal and it runs cooler than regular metal. Okay, so we got that off. Now, look at the armature here. It definitely got hot. You can see how brown that is in the middle. So it got hot at some point. The washers are kind of gooey. Let's clean them up and we'll give this a test run. New washers on there, but right now I just want to clean it up. Okay. Taking that off. Some liquid gold. Okay, throw that away and do another one. Like to say in Monty Python, my favorite line now is always changing from Monty Python Holy Grail, pull the other one. Every time I try to get something that's stuck, I say that to myself, pull the other one. Okay. We got most of the dirt and grease off here for testing purposes. Okay, now we're going to do a little tray. You can kind of watch here. I know this is so entertaining. I mean, you know, I would definitely give up a Friday night to see somebody cleaning bearings of grease. I mean, flat felt washers. Getting the grease off of them. Liquid gold. You can get it at Walmart. You can buy it at other places. But, you're going to pay through the nose for it. Most of the time they don't even have it in stock. If you buy it on eBay, well, you better break out your big credit card because it's going to cost you. I used to joke around and tell people that, well, it's going to be X amount to redo your fan motor and another $50 for the alcohol pint of alcohol that I need. That didn't go over very well, by the way. So if you're working on these fans, I wouldn't advise telling the customer that. I don't know. I believe in honesty, so I kind of like to tell them, but then again, you know, maybe I'm stretching it a little bit. Get rid of that. Try again. I just didn't clean it now. I'm gonna probably put new ones in there anyway, but you know, this one here is oversized. I don't have anything like that. Actually, I don't even think that belongs in there, to be honest. But rather than get grease constantly on this and that and the other, it's better just go ahead and clean it because you're going to re-grease it anyway, you know. All right, so we'll put that back on. That goes on that side of the shaft. And that's much cleaner. A little bit of paper towel there. Let's get that off. Actually, just so we got a nice low current connection, we don't want to draw too many watts. We'll put a little bit of oil in there. Alright, what I do is I put a little bit of oil between the bushings. Get that hair off there, let go. Right. And then, you know, that way they slide around each other a whole lot better. Put a little bit on the shaft. You don't need it because we're going to take this out and redo it all. But just to be safe. In there, kind of nasty. You get a little bit of that out of there. Get another one of these guys. That's the other thing. You're going to go through paper towels. So working on these fans, be prepared to go through some liquid gold and some paper towels. Okay. And let me see if I can get that. Wash it out of there and clean it a little bit too. And there she is. It's messy. Oh, that's got to be cleaned out anyway. This is just making it easier for later on. Okay. When I give it power, I like to know it's going to spin and not draw a lot of current. This one's rated at 1.3 amps. That's pretty high current.
It's pretty clean. It's just wet with alcohol now. I don't know whether it's something on that side. That's kind of weird. Actually, I don't think I'm going to put that one in there. And we got two in there. Now I'm going to move that to the front where it belongs. Let's move some of that fluid out of there. Okay, let me grab a toothpick. That's it. We'll clean all that out really nice when we clean out the gearbox. And I just don't want it in my way. I'll put these out of the way. Put this guy back in there. Okay. Nice, nice, nice. Now let's clean this one up a little. And let's get a washer vacuum at the bottom. Okay. So it does have quite a bit of washer in there. Alright. Well, maybe we'll put that other one in the back. You can tell when you get it all assembled, tighten the bolts down. This shouldn't move much. I mean, you should have a little play. You don't want it binded, but it shouldn't move much. If it moves much, add another washer. If it feels too snug and it don't want to move, like about 16 to maybe mostly an 8, between that range. If it moves too loose, add another washer. Too tight, take a washer out, and that's basically how you do that. Because you want it lubricated, you want it easy to spin, you want it to spin for a while, you don't want it binding, because that drives the current up, heats up the coil, and that's not a good thing. You want to keep it running cool. You don't want that armature getting like it is, all brown. You want that armature to stay cool. You don't want that excess heat. Now, with 1.3 amps, that's the rating of this fan, you're going to have some heat. You're going to have it because you can think of it this way. 1.3 amps times, say, 120 volts gives you a ballpark of the wattage. So it's not exact because the current and the voltage are out of phase, but figure 120 at 1 amp would be 120 watts, and another half of that, or another 40 watts for the 0.3, and you're drawing some wattage. Well, consuming wattage is heat. That's how you use up watts. You use it as heat. The more watts, the more heat generated to dissipate that amount of wattage. So that's a lot of wattage. So you're going to have heat when you're dissipating 140, 150, 170 watts. Okay. Clean that out pretty good. Now this side, these don't really do a lot of good unless you have that ball bearing in there, because they go right through. But I'm going to just put them in there. Actually, I'm going to put a little oil on that. And I'm going to put that ball bearing back on. I don't like to have to do that, but we're going to. And eventually I'll get it sliding on and off where it'll be so much easier to do. And you're saying, Paul, why are you using so much oil? It's better to grease you with, my dear. Okay. Look at the dirt and crud in there. That's what comes through the fan. That too generates heat. Anything that creates friction or encloses the airflow, and see, the way these fans work is, as far as cooling, is as the armature is spinning, it's spiral shaped. So it's actually like a propeller inside of a propeller. And that internal propeller pulls the air through the fan and cools the stator, the coil. And when you get a lot of dirt in there, that creates friction to the air movement and more heat. The reason you want that air moving is to dissipate that heat, to get rid of it so it's not in the fan. Okay, let's see. Where's that? Oh, stuff. Right in front of me. Nice new basket there. I love it. Ooh, that leaves something to be desired, don't it? I think we'll be putting a new head wire on there. Alright, let's see. Okay, let's see if I can find the bolts for that. Actually, I gotta put that back onto wherever I put it. I did it. There it is. Okay. These in there. Okay. You know what? I gotta do it. You gotta do it. What the hell? I'm messing with it. Okay, it's 20 bolts. Yeah, I should just do a little bit of bolts for that. Maybe I'll do with them later.
Okay, that's a cool looking gasket. More. It's all like it's all from the speed coil. These bolts go here. Two go in the speed coil. So how many we got? 1, 2, 3, 4 of those. 2 of these. And those go in there. Yeah, that holds that on. Okay, we got those still in. Okay. And it is these. Yeah. Okay. Yeah, this little magnetic dish is not far enough to the boss. Okay. Now, we got a buddy came and visited. He's kind of flying an ant. Go back down that way, I would assume. And so that's where I'm going. Oh, I got it. It looks right on that armature. That shouldn't be doing that. Let's see if we can figure out a way to do that. Maybe like that. Maybe at least there. Okay, that's off the armature. I don't know if that's the right screws, but we'll find out. That just seems really strange. I mean, we're going in, and I'm gonna do that. Shouldn't be like that, I wouldn't think. I guess it is. I don't want to use machine thread screws. I mean, excuse me. Let's verify. Yep, that'd be the ones. Just don't want to force anything in that don't belong there. And I didn't like the feel of that. So, another trick. I'm not sure if the screw's going right. Put a little oil on them. It's unusual to see that wide of thread, and you are not going to buy them. You mess those up, you're going to buy a whole new pot stand, but you ain't just going to go to the store and find those. Okay, that feels much better. I feel comfortable screwing that in there. And I don't need but two, so I'm going to just drop the other thing. Alright, and this guy. The dirt oozing out. A little bit tall.
Let's see, what do I got? That would be good for that. Aha. I see something. Stuck on a magnet, but I got it. I think that'll work. Ah, yeah. I'm not hitting the armature, I'm just hitting the wrench and my thumb. Okay, he's in there. His job is to keep the armature centered. Okay. And I gotta push it back a little more. So, to do that, we got a lot of play in this one. So we want to push that back, but we want it to be away from the back of the gearbox. You don't want it all the way in there. And that seems pretty good, actually. Okay. Good enough for testing. Now, next thing, we gotta check the field coil. The stator coil. We'll put this guy here. Can you see him? Yeah, you can see him. And I got little alligator clips on them. And it makes it easy. What's going on here? Go into my DC power supply there. Alright. That's what I want to see. Okay. Oh, there's one more check we can do. Let's see. Put that back on there. Do that again. Now, I'm not zeroing out the meter, so just realize that the ohm reading is not exact. It's just ballpark that I care about at this point. Okay. And can you see that? 9.9 ohms? Let's see, let me move it a little closer there. It's going to change, but yeah. I'll try this side. I'll stay on that one. Yeah, you should be able to see that, right? Yeah, okay. Look it. See how that turns? The resistance is a spin it. Sign of a good coil. Okay. Now we're going to power him up. And Jim needs a line cord. Let me go find one. I just happen to have the perfect suicide cord for this task. This is a nice old cord that it's not polarized. It's dried out. And it's perfect for suicide testing devices. So we need the end. Okay. Let's put that side. Oh yes, this cord leaves lots to be desired. Check that out. Look at that. Talk about corroded. There's corrosion galore in there. Can't get much more interesting. Don't even bother twisting. I just twist them together. Okay, let's plug that in and see what happens. I'm plugging it into my Variac, current limiting device. Ooh. Come on, in baby. 450 milliamps. In you. Well, we got no short so far. That's a good sign that we're not spinning. Why we're not spinning? This thing uses capacitive. This one ago, there's a lot of vibration in this stator. I don't want it like that anymore. I have to have it. It's trying, but it's also drawing some current. Not a lot, 0.5 amps. I may have to take my current limiting bulb off. Yeah, it's wanting to go. Look at it. Look at that. He's saying, let me spin, man. Let me spin. I want to party. Okay. I'll shut him off a second. Bring over the holder. I don't have to. Alright, so now we gotta find that. It's not those. It's in here. Let's take you out of there for a second. Have a seat. I got my power off, so okay. That guy, I wish they didn't ship him. That's a speed call. I just don't know. What is that? Power. Is it power? Speed call, basically. Switch. Used to be switch. That's probably what I'm looking for. Okay, and it should be some guy. You can look like some guy. Maybe. Maybe that comes down here. You must be. Yeah. Okay. Alright, let's try it again. Boy, this is one top heavy fan. Come on out of there. Yeah, that's top heavy. Beyond belief. Okay, can you see that? No, it's been you. A little higher. Higher. Okay, bang. A little higher. I don't think you really care about the base so much at this point. There's the fan motor. And we get a piece of paper. Piece of tape. Okay. Your job is to stay on it. We'll try it again. We'll get my suicide probably. Ooh, it's safer area because I'm probably going to turn off my bulb on the strip. Let's see what we get. Okay, we're at 50 volts. 6 650 milliamps, and rookie. Turn him up. Whoa, that didn't sound good. What happened to you? Alright, hold on. There's always one way to do that. Let me back off a second. We're going to take this guy out.
New. Let's see. I need to see them.
Break my screwdriver out here. Good one. Wow, he's tight. Oh, boy, that guy's tight.
Big boy screwdriver.
This side.
Come on. Oh, those things. Little boy screwdriver. Yeah, come on out of there. Let's see if I can loosen a little more.
Wow, this is really tight.
Somebody is. It's coming. There's always one thing. Oh, geez. Thank you, Lord.
Without the Lord, I don't know where I'd be.
Right there.
Yeah.
Let's see if we can get that out of there. Let's see if I can get these days out of here. Okay.
Yes, you can see it. It has a little washer. You got to get out first. And what you're hearing is me trying to get the washer out, not playing with the gear. I'm not doing that to that gear.
Here we go. No grease monkey has gone before. Oh, look at that. Let's see if we can get around it now. Come on, I'm going to have to pull it out. You're going to, aren't you? Let's see. You're going to. Okay, we're going to take this off. Hence the 2 screws only deal. There's the troublemaker. I go. Him. He's the troublemaker. Now, the screws back. One screw. In there. In there. Come on, line up. Here we go. Come on, the light. Is it still on? What are you doing here? Get in there. There we go. Come on, you're on the floor. This is the problem with doing this when it's on here, but I have to have it on there to test the motor. You bring everything up and you're on here, it's not easy. Yep, you're using that one now. You going in now?
Huh.
Okay, now you copy it. Now you copy it all the way down. I think that's great, yeah, that's great. Okay, let's try that again. Let's fix this down here, yeah. Give me good vibes. There. That should be better. Take the wire. Check. Crank it up. It's alive! Now what you really think about doing that? Okay. No. You can't do that. It's even tricky, so you won't do that. Like that, I'm really tight the knife. Like that. I'm going to keep it from popping around. I need to go the other way to keep it centered. That's what I need to do. I need to go the other way. That's a little better, but I don't need to be that much. Not very many. I can keep it from rocking forward. See, that's what I'm talking about, that space. And I could adjust it. I can bang this on more, but I don't want to do that right now because I need to get it back off, so I don't want to push it all the way back. As long as we're not hitting the back of the case, and we're not, at the back of the worm gear, on the back of the armature, I've got plenty of room in here. See, I can wiggle it before it even starts to turn that. You see, it's still trying to turn. And I'm only at 42 volts.
It's at 42 volts. It's drawing a half an amp. So let's bring it up. What I'm checking is the armature itself to see if it's got any really bad bends in it or warps, like if there's a bang. Don't pay attention to that. That's just so you can see that it's turning, and you can see that, yeah. Okay, let's turn you over there where it's at. Now that noise is what I'm checking. I want to make sure that we don't have a bent armature. And normally you can tell if it was bent, this thing would be jumping all over the place. Some of that vibration you're hearing is just heat, you know. It is what it is. What happened to my can of goofy oil? Put a little oil on that. That should quiet it down a little. Okay, I'm only on 71 volts, so this is like on super low speed. We're only drawing 0.9 amps, so we're not even up to an amp yet. I'm going to bring the voltage up higher. That's what I want to hear, nice and quiet. 0.7 amps at 87 volts. That's good. That's really good. And no problem with the armature this way. Now bear in mind, this cap ain't all the way on. It snaps on, it'll be a whole lot better. But I don't want to snap it on, I'm checking it. And as long as we're not drawing a lot of current, we're good to go. We're at 0.73. So let me bring it up to 100 volts. Okay, that's 104.4. We're drawing 0.89 amps. We are great. Go up higher. 115.6. We're drawing 1 amp. And it's rated at 1.3. You see how just making sure it's not bound, how that affects the amount of current draw? This thing is running great, even with the case not all the way on. It's nice and cold, not dissipating a lot of heat. It would run like that for a long time without any problem at all. But we're not going to leave it there. Turn it back down and shut it off. So we know the motor's absolutely fine. Now, let me get this little washer here that's on either side, and then we can get it right before he falls out. That's just basically, I gotta clean out the gearbox, and this little guy that was in there, I'll show you where he goes. I'll get grease on my hands. Basically, he goes on here. And that's where the worm gear goes into the other side of the case. A lot of screw, and let me show you this. I'm going to take the camera off the stand, and I'm going to show you a few things just so you'll see what I'm doing and what's going on with this fan so far. Now bear in mind, this is just an initial width. We got it on the bench. We want to see what it's going to do kind of test. So, let me take this off. Stand here, bear with my hands. So I didn't lose you. No, I didn't lose you. Okay. Let me show you what we got. Let me turn this. And I'm going to bring a little light source over here so you can see. Okay. A lot of people think you can just unscrew that big nut, and that's why they're all chewed up. You see how this one is? That's why they're all like that. Every single one you ever find will be like that for this age fan, unless you had one that's been owned by passed down to an infant, and they're now 95 years old and they never had the fan worked at. Other than that, they're going to look like that. And the reason is this little screw. See that little screw in there? Right there in my fingernail, my dirty, filthy, greasy fingernail. That screw locks that bearing, that bolt from turning. So this bolt here, this guy, he puts tension on this worm gear. That shaft of the worm gear goes inside that hole. And as you're tightening this in, you're putting tension on that worm gear. You over tighten it, what happens? It don't want to turn because it's wedging against the back side here. So you over tighten it, then it won't turn, and that's going to drive up your, you're going to stop the armature from turning. You really overheat the motor. If it gets loose, it can bind up and break the shaft. So what they do to keep this from getting loose or tight, or people over tightening them, they put this mechanism here. When you tighten that screw down, it tightens this in place and it can't change, so it's factory set. And you can see the line where it was screwed in too. So when we screw it in, we're going to screw it in so it's snug, so that there's still a little play in the worm gear left and right, where it's not bound, but not much play, almost stationary, but still free turning. Of course, we got to get this gear out. That washer on top is the one I was fighting. That's got to come out, and it's slotted. You see the slot there? It's got a little pin that goes in that slot, so you can't turn it. You got to go straight up. Then that gear on the bottom comes out, and then we got to pull the armature back out, clean out all this gunk and grease, and we'll re-grease it when we reassemble it. And that's that. Okay, now, the other thing I want to show you is what I was doing. Okay, the first time I ran, I had my light on, which is a current limiting bulb. It's that light bulb up there. It's not really made for a fan. It's not a high enough wattage bulb. It's made for electric tube radios, but it works. It's 100 watt. Usually on a fan, you use 300 watts. Well, this gives me enough to know that when I tried to spin the armature by hand, I could tell if it was trying to turn. If it was trying to turn and was turning a little bit, then I know that the motor's okay to give it full current. There's no dead short. So at that point, I can turn the voltage down, shut this off, shut the power, put the power back on, and bring it up. Now, watch when it first starts turning. Okay, there it goes. All right, so now we're at 57.9 volts, or 58 volts AC, and it's turning. That's amazing. That's really good. It's drawing 3/4 of an amp, 0.75 or 0.74 amps. Okay, so that's good. And so then when I bring my voltage up higher, you can hear it in the background. All right, so they were at roughly 87 volts, drawing 3/4 of an amp, or 38 watts. Okay, and both amps are 64%. Power factor is 0.58, not bad for a fan at 87 volts, and you see it's spinning fine. And the rattling you're hearing is just the armature shaking in an empty can. There's no grease in here. They say as it gets lubricated, it quiets down a little bit. And the shaft's fine, it's not bent. Those are the things you look for when you're working on one of these fans. So if you're ever working on one of these GE fans, you got to remember that that pressure knob that I had to fight to get off, that it's not a bearing, it's a bushing. That bushing needs to be snug enough to hold the armature perpendicular to the motor. If it's too loose, the armature is going to wobble as it turns, and if it's too tight, then you're putting pressure on the motor and it ain't going to want to turn. You're bearing it down. Anything that's going to cause stress, over tightening this, over tightening that, is going to push this wattage up. And if you go over 1.3 watts, the fan's going to overheat because it's not meant to go higher than that. That's its operating wattage. And so you want everything smooth. You hear how quiet that is? Even with a floppy piece of paper on there and no grease. That means it's well lubricated. Even at this crazy cockeyed angle, you see how I got it. It ain't even straight up and down. And it's tilted the other way on top of that. That's great. That's a perfect test for a fan motor because you're putting totally out of kilter. If it's going to rub anywhere, you're going to know it now. You're going to hear it, you're going to know it. You're not going to have that nice peace and quiet fan sound that you're hearing now. So anyway, Shut it off. And of course, you always do it with a suicide cord. You know, get used to working with suicide cords. If you're going to work on something like this, you got to be brave. So, you know, if you don't take your life in your hands at some point, you're really not meant to do this. Okay, so the next thing I'm going to do, of course, I need to show this video to the owner of the fan so they can see the fan in action. But, you know, mostly it's for you guys that are learning how to work on them, so you get an idea of some tricks of the trade as we go along. And you see, if I'm looking in there, I see another loose washer. See it under there? That's just a end seal washer. It don't matter, but look for those things because you don't want nothing binding up inside. Now, that wouldn't have caused any problem because it's nowhere near that worm gear. It's down in that, it was below the shaft. But, you know, take your time working on them. Remember everything you're doing, and you won't have a problem. I'm amazed that this one still has its oscillator intact and connected, and it's working fine. It's even got the original, it looks like the original brass washer in there. Of course, now again, you're going to want to see all the dust and dirt that gets inside there. Let me put it right in there. You're going to want to clean them out. And you're going to want to put some oil in there. See it on top? It looks cleaner than in the camera than it really is. There's dust and there's dirt, and it works its way in here, and it creates friction in between this. That also will bind on the motor while it's oscillating and trying to spin a fan. Same here. This is dry as can be. That's dry as can be. There's no oil, nothing in there. So oil them from time to time, and when you're working on them, make sure there's oil. And the screw is loose, you see. Oh no, I'm sorry, it is loose because I turned it by hand, but it's reverse thread. Now some of them are reverse thread, you know, some of them are not reverse thread. This one is reverse thread. So when you go to tighten it, or when you go to take it off, you got to turn it the opposite way that you would normally turn it, obviously. So bear that in mind, and when you go to tighten it, same thing, you got to turn it in the opposite direction. But they're not always that way, so don't over-force anything. You know, if it don't go one way, try to figure it out. Is it reverse thread, or is it just really tight? You know, try to go both ways and see if you can, like, loosen it a little. Don't overdrive anything like that, because if you break this bolt, you're going to have a hard time finding another one. You might have to buy a $50 or $100 Potts fan just to get that stupid little screw. And believe me, I've done it. So I know what I'm talking about. Be careful. And, you know, you're free to try this at home even though I'm a professional. Okay. The next thing is the speed control. We got to get that situated. Not a problem. What I'm going to do right now before I end this video is check the speed control with the ohm meter, make sure it's okay. Once we know that's okay, then we know we're good to go as far as redoing this fan and putting it back together. And then I got to upload this video. That takes about 5 hours. After my editing, I got to edit it and then upload it. It takes about 5 hours so that the customer can see it, and then we start working on it. I still got a couple other items that really are ahead of this fan. Been swamped with work because, and it's a good thing, I thank the Lord for the work, but because of the pandemic, a lot of people are home right now, and a lot of people are not working, or they're working from home. So those projects that they were like, well, I'll do that when I get around to it, and you know, they never go out and buy one of those round to its. Well, all of a sudden, they're finding round to its all over the place, and people like myself who do service work are getting swamped, you know, and of course, I'm a one-man shop, so, you know, it is what it is. It sets me back. So just be patient. If you're one of my customers, I ask that you please just be patient. We will get your fan working great and get it back to you. And I apologize for turnaround time. It is a slow process. There's a lot to do. You know, it's not an easy thing. This gentleman knows that because he's had it apart, he's obviously done some of the work to it. He knows how much time you can rack up in a project like this. So, okay, so anyway, enough of that soapbox. Let me get back to work. And so what I'm going to try to do is strip this wire one-handed. Ha! No, not good. It's double insulated. So we'll go with that one. Nope. Okay, I'm going to have to set the phone down and strip these. I'll be right back. Okay, we're going to, well, first I'm going to zero out my meter, just so we can get a little bit more accurate numbers. Let that stabilize. Close enough. Okay, now, the gentleman that owns this fan was nice enough to put these little color-coded, these papers on these color-coded wires, and that helps. This is one wire, that's basically the power coming in. Okay, so back to the first gear. First speed is almost a dead short, 0.4 ohms. Okay, second, 0.8 ohms. Third, 1.6 ohms. So you see they're going up as we go. So this fan's, what I'm assuming is that this goes from this 1, 2, 3 here. I'm assuming that it's high, medium, low. And the reason for that, on most fans, it's not always the case, but on most fans, you have the lowest resistance on high, of course. It's almost a dead short, and it is a dead short. That's why it's showing minus volts, minus ohms. It's the same as what I did with the suicide plug, basically. I connected it directly there. So these two lines are pretty much the same. So you got a power coming in here. You got one wire going up to the fan motor. The neutral goes directly to the fan motor. The hot comes down and connects to the wiper, which is, where's the wiper? And this one has a switch. Yeah, this one has a switch. Okay, connects to the switch. And the switch, the wiper on the switch goes, which is the positive, would go to, probably go to this one. This looks like it came out of the switch. So from here, it would go to here, which is pretty much a direct short, high, that's high speed, to part of this coil, which is second speed, to the next part of the coil, which is all of the coil. So this is like a center tap off these two, okay? But it is working. It's a very powerful inductor, so it's got really thick winding in there. The wire is really thick. And it would have to be because it's a 1.3 amp motor. It uses a lot of power. It has to be able to draw a lot of power. And it's got a date code on it. It's a 28 week of 1930, could be. I don't know, 418. That might just be the coil number. Yeah. Okay. Anyway, so the next thing is to put that back in and run the wire. I would suggest putting in a new head wire. This wire is short. You see how messed up it is. The customer, I don't know if they wanted me to use some of this. Okay, so the next thing is to find out if the customer wanted me to cut this cord and use part of it for the head wire. I don't like the idea of doing that. It really needs to be a thicker cord. And I need to give some feedback to the customer. I would not use this on this fan. I mean, I'll use it if they want me to, but I would recommend against it. It is polarized plug, and you know, I mean, let's hold on a sec. Let me show you the cord I use on these things. and what I do, and then the customer can decide. This is more of what they had back then. This is a cloth covered cord. This is a new cord, brand new cord, made in Massachusetts, made in USA. Amazing, something still made in USA. It's cotton covered cloth over a vinyl insulator, and trust me, that thing is stiff, that round outside layer. It is really strong, and it has a ground, a hot, and a neutral, and they're all 18 gauge copper. This is a very good cord. This is the kind of cord, as you can see, that was on the fan originally. That's what this would be. Now this is only a 2-wire, whereas this is a 3-wire. But what I normally do is when I change head wires or put a line cord in, I use this because it's the right era-specific replacement. Additionally to that, I put a 3-prong grounded plug. And the reason I do that is because I can ground this, the green wire in that cord I just showed, I ground it to the case. And that grounds it and brings this up to modern safety, because now it's grounded. You don't have to worry about getting shocked because, you know, the plug is polarized. It can only go in one way. It's a 3-prong plug. But also, with this ground line connected, it's connected in your circuit panel to ground outside to a grounding rod, and that protects you. All modern appliances use a 3-prong ground. I strongly recommend it for an antique fan because these stator wires, you can see what happens to them. And when that happens inside, or if it gets bound on the rotor, God forbid it shouldn't, but if it does and it shorts out, you can get one nasty shock from the case. With this, you're safe. Kids are safe. Well, kids are not safe because they shouldn't stick their fingers in the back of the fan, but I used to when I was a kid. Anyway, you're safe electrically because you're protected from a shock. So I would strongly recommend using this in that much heavier gauge 3-wire system. And then since this is a 2-wire head wire, I would run the same wire up to the motor here, and I would ground it inside. It doesn't really need to be grounded here because it's grounded through everything else. So I would actually, normally I just leave it there for added strength, and I don't connect it in the head because that's one more area that can cause an issue down in the motor. You know, you don't need that. As long as it's grounded here, it's grounded. It's grounded through here, and it's grounded all the way. But I would strongly recommend using a grounded 3-prong plug, not a polarized plug. This is great for a tube radio. If you want to make a tube radio look old, like an old style radio, this would be great for it. I'm also concerned with the gauge of this wire. There's 2 wires in here, and I'm thinking they are 20 gauge, maybe 22. That's way small for 1.3 amps of power. I would not use this. I mean, that's just me. I would not use it. If you want me to use it, I'll use it. But I would recommend that other cord that's 18 gauge with a ground. So anyway, I got to go upload this video so I can show it to the customer. It's already over an hour long. I appreciate you watching it, and by the time I edit it, it'll probably be under an hour. If you found it informative, please consider giving me a thumbs up. And as always, I will continue this video with a follow-up video, and we'll go right through redoing this fan. So thanks for watching.